Hello, everyone. I'm Meher.
My name is Abigail.
My name is Maya.
I'm Mira, and our project is Early Detection of Alzheimer's Disease with Convolutional Neural Networks.
What is Alzheimer's? Alzheimer's is a progressive fatal disease that shrinks the brain and is created by the loss of function in the brain cell connections. It is the most common cause of dementia, and it's the sixth leading cause of death in the United States. It is a major nationwide problem, with an estimated $277 billion in 2018 spent on managing medical and social welfare of 80 patients in the United States alone. Early diagnosis is key to combating this disease and could save an estimated of $7.2 trillion in medical and care costs. What causes Alzheimer's? The brain has 100 billion cells, and they're connected to perform specific functions. These connections can fail, resulting in a loss of function. The destruction and death of nerve cells is what causes memory failure. The risk factor depends on a patient's age, family history, and genetics.
So the most common approach for detection is noticing mental decline, but unfortunately at that point, Alzheimer's will have caused severe brain damage. So imaging is among the best approaches for early detection of Alzheimer's disease. And while the progression of Alzheimer's does cause brain shrinkage can point to many different conditions aside from Alzheimer's. Having a model that categorizes the stages of dementia would be able to detect mild shrinkages in certain regions of the brain. For example, the hippocampus, which may be an early sign of Alzheimer's. And our models do just that and detect abnormalities that allow for early diagnosis of Alzheimer's, which can result in better management and prediction of disease progression, even though there isn't a cure yet. So the data set that we used consists of over 6,000 MRI images of the brains of 150 individuals aged 60 to 96 who were each scanned at least once. They were all right-handed, and these images were classified into 4 groups. They were labeled non-demented, very mildly demented, mild demented, and moderate demented. And one of our limitations with the data was that even though 6,000 images might seem like a lot, it really isn't a sufficient number to train the model for high accuracy. So we augmented pictures using an image data generator, which zooms and reflects images to add more data and to balance the data set overall. And these are a few images.
In both our first and second model, we used convolutional neural network architecture to detect Alzheimer's using images of the brain. Detected into 4 categories: mild demented, very mild demented, non-demented, and moderately demented. We varied the number of layers to increase the accuracy of the detection. Model 2 used generators instead of lists to use data and store it, and used it to augment images to make the data set bigger so the CNN had more images to train on and improve.
Model 3 was a modification of the VGG16 CNN, which is a famous model known for being highly accurate in image classification. And we trained on augmented images, zoomed in and reflected. And those images were generated using generators. And Model 3 ended up being our fastest and most accurate model. So now a summary of the results. Model 1 had a test accuracy of 55%. Overall, our observations were that it was slow and computationally expensive because it used lists instead of generators. Model 2 had an increased accuracy of 60%. This process was faster because of the generators, and because of the augmented images, we were able to get a higher accuracy. And Model 3 ended up being our best model because it used the powerful VGG16 CNN architecture. So this means from Model 1 to Model 2 and then Model 2 to Model 3, we were able to increase the accuracy for dementia classification by adding image augmentation, generators, or powerful architectures. Similarly, with a larger, more balanced data set, more image augmentation, and we can make models with higher accuracies. By making changes to Model 3, it can serve as a basis of a model that can help doctors in diagnosing Alzheimer's disease early on and improve the livelihoods of millions of people. Thank you.